Thank you. Oh, um, let's see. Yeah, so I'm here to talk a bit about what I see in trends in protocol evolution towards a more privacy-preserving internet. As I said, a lot was already taken. I think I've been really working a lot with standards, especially in ITF, and I've also been transport area director for a total of 6 years, trying to move standards so you can use them. I think my proudest is probably, especially now in the pandemics, is my contribution to WebRTC, which ensured that you had well-working video conferencing. So, yeah, let's move on. So, there's many individual smaller or pieces of user privacy improving efforts in the protocol space in ITF. And I think this is great for the users. There's a clear need. I mean, a lot of the internet protocols show their age. The landscape's moved on and all this. The need for thinking about the security and the threats are much bigger today. But make some observations together with my colleagues around these activities. And I will look into a couple of examples here, or saying a chain of protocols, how that relates to each other, I think, and their efforts. They really target to improve the user privacy and the security, but I also think they have potential for implications for the networks. I mean, one such aspect is traffic classification. If you're doing that, sure, we can start or continue doing some kind of arms race around machine learning, etc., on traffic patterns, and I think that's going to happen to a certain degree. But when you take away some of the other aspects been done, also the traffic patterns in itself can, on a smaller scale, I think, be affected here, with more aggregation of what would before would be many smaller flows into bigger flows, and pinning those to a number of proxies. And I guess that's already ongoing with the, so to say, decentralization and cloudification and larger providers. But see a need for certain type of management activities to find alternatives, how to work with that. So come back to that at the end. So one of the latest, and I guess now carrying a lot of traffic in internet. I mean, one of our mobile networks, I know, they reported they gone past over 25% of traffic is quick today. And this is now less than a year off. I mean, now it's been years since the RFC came out. I mean, Google has been running for a while before that, and so. And I assume you know these details. I mean, it's secured, and especially with the TLS 1.3 handshake built in, it encrypts and integrity protects the payload as well as the transport protocol headers. And here we come to the classification part. I mean, quick leaves one single byte unencrypted. And there's the initial long header packets, and there's a bit more, but in the short packets, there's on this slide, you see it, it's header form saying it's short, it's a fixed bit, it's a spin bit that can potentially vary, there's 2 reserved bits, a key phrase that will vary, and two bits that tells you how long the packet number length is. It's not a lot of things to latch on and saying detecting the protocol. So you're down to UDP. It's a UDP 5 tuple. Sure, it's in most cases today it's going to 443. It's some type of HTTP web traffic and what the IP address is, but yeah. Quick goals, I mean, it's a lot of implementations in user space is easy. There's a lot of freedoms to implement this. There's internal transport header extension parameters that you can configure. There's a lot of flexibility here in implementation going forward. So how this protocol really behaves, how well behaved it is, that's a good question. And I guess some of you will probably see some of this quick traffic being not that nice, potentially. And it's going to be hard to detect and figure out which implementations is doing this, and are actually, from a network perspective, knowing which implementation it is. So, yeah. The next mechanism here is TLS encrypted client hello. I mean, the server name indication for those who want to determine where is this user trying to go. It's been classical to look into the TLS handshake and say, okay, he's going to this domain. If do classification based on that. The intention here with the encrypted hello is to put a stop to this. And it works, I think, especially well when you know that you're going to an IP destination that fronts a lot of different domains, like a CDN, because then the solution with actually encrypting the real target prevents further determination of which domains are you going to. So, and it works in this case by actually having a normal TLS client hello. But it's targeted towards the what's called the encrypted client hello provider, the one who has the key. And then you will encrypt the real one, and there you just put in this SNI and, for example, ALPN and the rest of the things that you would have in a normal unencrypted before. It has a nice property that if you actually have a stale key for the encrypted client hello provider, it will immediately get the real key and can request it. So this is one mechanism to really try to say, okay, you're not going to really understand which domain are targeting unless you can figure it out in other ways. So DNS protection. Transport encryption of DNS requests is finally going somewhere, but yeah, I guess there's a number of different solutions on the table already. You have DNS over TLS, DOT, you have DNS over HTTPS, DO, and DNS over QUIC now with some. But yeah, as Mikael before pointed out, it's like, yeah, the resolver will know quite a lot about what you're asking, etc. And I think especially for these centralized, when the information is going to larger, you have a lot of data, enable them to coordinate or understand what it's going. So one way of trying to do something around this in privacy is is the oblivious DNS over HTTPS. So it's trying to ensure that the resolver doesn't know who the client is, and the proxy that forwards the traffic will not know the request. Functions through client encrypting the query with using hybrid public key encryption. The key comes from a DNSSEC protected DNS record that you fetched before. And you send it then forward through the proxy that removes the IP address, say, of the source. Send it to the resolver. The resolver resolves the query, and then re-encrypts the answer using a key from the query, and sends it back, making its way back to the client who can decrypt it. So I guess it improves that relation on knowing what the client is, but then we're back to, I think, what Mikael said about, well, you can still in certain cases correlate it, but at least it moves the privacy aspect here forward. But yeah. People, of course, looked at this idea and saw that it's useful in other contexts too, to try to do the same. There are ongoing work in working group OHI on oblivious HTTP. The same thing is trying to ensure that the server doesn't know who's asking or sending data or retrieving data from the server. But here, clearly, it's not the general placement. There's a lot of, in normal HTTP usage, there's a lot of fields that can leak information, and if you would actually try to fetch a full site, you still have the whole problems of cookies, web browser identification, all these things. So you would still the server could still very well identify the client. It's probably most useful, for example, for submitting telemetry that's from different clients that want to be anonymous. It's also, it could work, for example, if you're gonna go to like 1177 here and retrieve medical information about some disease, you could actually probably do that without leaking information about who you are and that you're looking into this. But yeah, in general, you need to be very careful, I think, about in this protocol usage to scrub them from leaking information, and that's gonna be a continued challenge, and why this, I believe, HTTP is not a general solution to preserving privacy for web, so or improving it. Now getting into what I worked a bit more on lately has been MASK. So it's an ongoing ITF standardization. It's about tunneling UDP and IP over QUIC. It uses HTTP or for control signaling, setting up the flows that you tunnel. It uses QUIC datagrams to provide unreliable, unordered forwarding of end-to-end packets or UDP payloads. And you can multiplex basically unlimited number of concurrent flows. So it behaves very much like any other VPN protocol, except it's going to be quick in the bottom. It's going to be, for now at least, congestion controlled. I mean, these VPNs or tunnels, they have this implication of the tunnel. If you're going to have any smarter AQMs, etc., that try to make the flows behave nicely to each other, I mean, that doesn't work, and that needs to move to the proxy provider, who's the one that sees all the flows and can do any kind of flow-related impact. And then we also into this question of saying, how are we dealing with any type of flow logging, etc., if you have requirements on delivering traffic data, etc. So we also have the pinning of the traffic through the proxy, I mean, affecting things. But yeah, it's it's been quite a lot of talk about Apple's private relay that they launched earlier, a couple of months ago. It's a private relay. It really using a chain of proxies, two of these, to try to achieve a goal where a normal VPN, the proxy or VPN server will know who's the traffic area, etc., and where it's going, and this try to address this so that neither of the proxies knows both where the flows is going and from who it's coming from. So, and here they're really going for saying, but those proxies needs to be operated by different entities. To ensure that if you're going to figure this out, you need to have several collaborating entities. So basically, you establish a quick tunnel first to the proxy 1, and inside that you do a second hop to proxy 2. But you can, yes, this is quick. You can actually do a little bit of trick with proxy 1 and basically run it in a quick aware NAT mode, basically, but we're using just the control channel to tell proxy 1 saying, hey, rewrite the phi tuple and the connection ID for this flow, so you can forward it to proxy 2. They also provide, to ensure that they have some geographical context, they actually let the client includes a little bit of geographical information on a regional level or on country or time zone towards the proxy. So, and they say that's also happening. They are using DNS over oblivious DNS to figure out to do the resolves here, and that they provide kind of the high bits for where is this request coming to get the right DNS replies contextualized correctly. So I mean the traffic classification in this case is very hard because of the tunnel lengths. Our customers, mobile operators, has had number of complaints about this from, I mean, both the content filtering aspects, they often, their services, etc. There, 0 rating, over this, of course, doesn't work. You become a lot of aggregates due to tunneling and pinning through the proxies. But surprisingly enough, from Apple is saying that when they looked into the performance here, they're actually getting quite good performance. And part of that is both Quick's behavior and the mask, which actually allows you to establish these new flows through these proxies without any extra RTTs. And in certain cases, by selecting the right, etc., they actually seem to get quite efficient paths to most services. So the normal deployment of the first proxy is, so far they've deployed it in proxy 1, I think, is Apple's is running it itself, and proxy 2 is run by some CDNs. So you basically have the CDN, so for a number of services you get good performance. So what can we look for the future, looking at these different forms of efforts? I mean, I see that the challenge here to seeing, we'll see slightly larger, fatter flows to smaller number of central ingress. I guess that's an evolution that anyway has been ongoing. The traffic management here, for certain, if you're doing a little bit more flow aware, etc., is going down. Interesting question here is about your legal requirements, and that maybe, I mean, it's once more technology versus law, who's responsible, and the need for shifting maybe who's doing certain of these things if it's going to be provided. And we also see, I mean, service providers also have an interesting challenge, especially for like with the private relay. So we can take a streaming service as an example there. Okay, the user might log in, but where is the user? It's behind the chain of proxies. Are this service provider, does it have a license to serve this user the content he asks for? How does it figure out this without telling too much? So that's a good question. I'll try to answer it next time how you could solve it. But as a mobile network perspective, I mean, there have been quite a lot of traffic optimization, performance enhancement, proxies, things like that, trying to make the radio be as optimal as possible, improving efficiency. And then also a number of these mobile operator provided services, like zero rating, etc., to the customers, that also fails in this landscape. So therefore, how can we do something about this? I see one way forward is to actually go towards collaboration. Embrace this possibility. Yeah, I think these proxies are going to be here for staying, to try to improve these privacy aspects. And looking at one of these questions, for example, the service provider wants to know where the user is. Is my license for this content I'm going to serve him, is that valid? Well, you could actually have proxy 1, who knows where the user is, attest to the service provider, yeah, this user is in Sweden. And that would be enough for this particular service provider, most likely, because he has a contract for this content in Sweden. Okay, that's all I needed. And you have minimal privacy sensitive information leak to the service provider. So, and this information then can flow either back through the client, or in certain cases you could actually allow a chain forward also by having proxy 1 talk to proxy 2 for this particular management information. But I think this is for future discussion. Or included in information back from the client forward to the service provider. So looking at this zero rating case with another, we could actually then also have proxy 2 tell proxy 1, okay, this is going to domain in the list you provided for domains that are zero rated. And therefore proxy 2 just reports back the volumes for how much should be zero rated. And that would be then with the proxy 1 being deployed, for example, with a mobile operator. And also, when we have these signaling channels, we see some potentials also for doing performance enhancements using signaling, etc. here, talking to the client, making the end-to-end flow works as well as possible by the information from the network. So, in conclusion, I see there we have potential for an explicit collaboration that is beneficial for both parties, or for all parties actually. Trying to find the right balance here, getting better privacy for the users, providing just exactly what the information is needed towards service providers, etc. And also improve this quality rather than trying to guess it or implicitly get it from protocols that wasn't intended. You can actually agree on particular specific the information you wanted. So that's potential future. So yep, questions.
Thank you, Magnus. Do we have any questions for Magnus in the audience? Yes, over there. Microphone to Michael there in the middle, please.
Hello.
Hey.
So I always find it interesting when people are talking about DOH and ODOH as a privacy control, since in many ways they give me even more exact data than the UDP streams. And this is because the recommended deployment is with key reuse. So I have an identifier for about 12 hours that's consistent for a particular client. What do you think about that one? Because that's all performance is measured with key reuse.
Yeah, that's that's not. I mean, yeah, you need a frequent enough rekeying there, so you're
Yeah, the default is 12 hours,
yeah.
and that's what all the numbers that if you look at any statistics on how well DOH or ODOH performs, those are based on the default key reuse timeline, which means that if you actually set it to change keys frequently enough to not be fingerprinted, it's going to increase load time significantly.
Yeah, that's a problem. Yeah, I mean, I think this interesting question also how much which DNS resolvers are using. There are other aspects here. If you're actually trying to spread your graces also and actually use more resolvers, you could actually potentially ensure that you have this basically striping your requests a bit also would also improve. So, but I think you need to do a number of assets. But yeah.
Agreed. No, it just it bothers me that all the statistics are based on a strategy that actually gives me better data.
Yeah.
My analysis.
Yeah. So. Okay.
Any questions for Magnus? Mem?
It's Mem from Netnod.
Yep.
I saw a presentation, I don't remember if the last half year or something like that, with DOH over Tor. What's the difference with this or running DOH over Tor?
Trying to think here. What would be the difference? It's similar. It's probably are some details that change in regards to the oblivious DOH. It's yeah. It's I mean yeah. It's not particular just that the DNS. So there probably are details there that makes it slightly different, and also how I mean Tor is multiple hops with encryption, etc. So it might be actually be better from the location chain following, but yeah, the question is, does it leak? What does it leak from the actual DNS requests?
Yeah, and I think that the implementation in that presentation changed the resolver like every second hour or something like that. So you gave away some information to one of the big providers for like 2 hours, and then you get the next 2 hours to some other resolver operator or resolver server. So
yeah, I mean the problem here, I mean, is your chain of requests or the combination of your requests for different names, which might leak information, and yeah, for that particular resolver. I think I have some colleagues also working on other aspects around this. Is the thing, if you're looking from outside, seeing the traffic going into your resolver, going out the resolver, can you try to make that by actually saying, okay, you need to fudge up the timelines, let's say, between incoming and outgoing requests, also but that's towards another aspect of this. But and I think that's where, I mean, Tor. If you're gonna track Tor, you need to be this multi-vantage point. You can track Tor also, but yeah, you're fairly big who wants to look into certain individuals then. But yeah, the state actors kind of level. So okay.
Any more questions for Magnus? Okay. Well, please join me in thanking Magnus for his presentation. Thank you so much, Magnus.
Thank you.